So in this video, we'll wrap up our discussion of SAT practice test number 8, section 4. These are calculator questions, and these are the grid-in questions at the end of that section. So in number 31 here, they tell us that we've got 2 atoms of hydrogen and 1 atom of oxygen and 1 molecule of water. How many atoms of hydrogen? So we don't care about the oxygen. How many atoms of hydrogen are there in 51 molecules of water? So there's 2 atoms per 1 molecule. If I multiply that by 51 molecules, so just a little dimensional analysis going on here, what I end up with is 102 hydrogen atoms and 51 water molecules. Next question says if x is equal to 1 in the equation above, what is the value of a? So I literally just put 1 in place of this x, and now I want to isolate a. So what I chose to do is add 1/2 a to the right-hand side of the equation, and then divided both sides by 1/2. And 1 divided by 1/2 is really the same as 1 times 2 over 1. You can do that on the calculator. You got to be careful. Use parentheses around that denominator, but you should end up with 2 for your answer for a. 33 is a little bit trickier than the first two. So they tell us that in the xy plane we've got the equation x plus 2y is equal to 10, and then 3x plus 6y equals c. They represent the same line for some value of c. What's the value of c? So what I think here is well, I don't necessarily know the right-hand side of the second equation, so I'm not going to focus so much on the right-hand side of these equations, but I do think I can make the left-hand side of this equation match the left-hand side of this equation. So if 2 equations represent the same line, the equations of those lines have to be some multiples of each other. And so what do I multiply x plus 2y by in order to get 3x plus 6y? You should hopefully decide that it's 3. So if I multiply the left side of that initial equation by 3, I do get 3x plus 6y. I would therefore have to multiply the right side of the equation by 3 as well, and that'll tell me that the value of c has to be 30. So here they're talking about Paul Revere. If he would have ridden straight to Lexington without stopping, he would have traveled 11 miles in 26 minutes. In such a ride, what would the average speed of his horse have been to the nearest tenth of a mile per hour? So you have to pay attention to units here, right? They want the units of this answer to be in miles per hour, and they do want us to round to the nearest tenth. So I know I have 11 miles traveled across 26 minutes. So if I just take 11 miles divided by 26 minutes, that would give me the average speed in miles per minute. Well, I need to turn that into miles per hour. So I'm going to multiply by a fraction with my conversion factor for minutes and hours within it. I want the minutes to be in the numerator so that I can cancel these units and end up with units of miles over hours. And if I break out the calculator and type in 11 over 26 and then multiply by 60, I get a little bit, I believe it was a little bit above 25.4, but it should round to 25.4. One thing you wouldn't want to do in a situation like this, don't type this into the calculator and round that off and then multiply by 60. Type 11 over 26 in, leave that in exact form, multiply that exact form by 60 so that you don't have some accidental round-off error that you incur. Number 35 here is one that, if you have access to the calculator, you should use the calculator to do it. A little dangerous to do this by hand. I guess I need to shrink this a little bit to show it to you. So they give the graph of the function f here. So f is this parabola. It's shown in the xy plane. They tell us the function g, which is not shown, is defined by g of x is negative 1x plus 10. Well, I thought negative 1x plus 10. That's a line with a y-intercept of 10 and a slope of negative 1. When I first did this, I actually made a mistake, and I didn't catch the mistake until I was double-checking my answer on the calculator. Notice the scale on the y-axis. If I go down 1, I'm dropping from 10 to 9. So what I'm trying to show is a slope of negative 1, since the coefficient of this x right here is negative 1. So if I go down 1 grid line, I literally have gone down 1 unit. But if I go over 1 grid line, check out how far I've gone over. If I go over 1 grid line, I am not at the x-coordinate of 1 just yet. So a rise of -1 and a run of 1 would actually be down 1 grid line and then over 2 grid lines just due to the weird scale. We don't have a consistent scale on the x and y axis here. So that makes doing this by hand a little bit tricky. Now you do see a screenshot from my calculator here. I'm actually going to bring my calculator up onto the screen. I believe I still have this there. Yeah, so I graphed each of these functions, f of x and g of x, y1 and y2. And then what you can go ahead and do is find the intersection. So I found one of the intersections. There are two acceptable answers here. They want a value of a such that f of a equals g of a. Well, that's going to be either right here where the graphs are equal to each other, or right here where the graphs are equal to each other. You see, I've already gotten one of those answers on my screenshot that's already pasted into the document here. And that first acceptable answer would be 2. So 2 would be one answer. Another possible answer, we'll go ahead and go through just so you remember how to do this. So if I want to find this intersection down here on the calculator, I have to go into the calculate menu, have to grab the intersect option, and the procedure for this is just to hit enter on the first thing that you have crossing at your intersection, hit enter on the second thing, and then give the calculator a guess. Now, I want to make sure I find this lower right-hand intersection, so I'm definitely going to arrow over close. I don't have to be right on top of it, but as long as you're much closer to that intersection than the first one, you see the other option that you could give, the other answer that you have the option of giving, I should say, would be the x value of 8. So either 2 or 8 would be the values that you could answer with here. Number 36 is kind of tricky. They give us a right triangle, and then they tell us that there's some other point W. It's not shown, and it lies on this stretch of the triangle, lies on RT. What is the value of cosine of angle RSW minus sine of angle WST? So what I did is I redrew the picture. I put angle W there, and I just wanted to try to kind of visualize what these angles were. Angle RSW would be there, and then angle WST would be back up along that same length, but then back down this other side. So I know up in this corner here, I have a 90-degree angle. That's a right angle on the original triangle. So these two angles that we're dealing with, RSW and WST, they're complementary. They add together to give 90. So if you take a if you've ever discussed cofunctions in trigonometry, if you have cosine and sine of angles that are complementary, so cosine of 60, sine of 30, 60 and 30 are complementary. They sum to 90 degrees. Those answers are always going to equal each other, and therefore when you subtract those answers, what you're always going to end up with is you're always going to end up with an answer of 0. So I showed that explicitly with 60 and 30 degrees being used as the complementary angles. I can do it with any set of complementary angles. If I take cosine of 45 minus sine of 45, cosine of 45, sine of 45, they have the same value. Therefore, when I subtract those values, I get the answer of 0. So the value that you're going to get for cosine of one of the complementary angles minus sine of the angle that it's complementary with, you're going to get 0. Last two questions here are based on the information that we have access to here. So there's a lot that they kind of throw at us here. We've got this information in the table, the minutes after an injection of penicillin and the concentration of penicillin measured in micrograms per milliliter that's in your bloodstream. They tell us that after penicillin injection, the kidneys start to remove the penicillin from the body, and this is kind of shown by the fact that the concentration of penicillin is going down in the 5, 10, 15, 20-minute periods after the injection's been given. Number 37 here says, according to the table, how many more micrograms of penicillin are present in 10 millimeters of blood drawn from a patient 5 minutes after the injection than are present in 8 millimeters of blood drawn 10 minutes after the injection? So this is kind of weird because there are a couple different calculations that have to be carried out, and then you have to take the difference between the two. So the first one that needs to be recognized is we're looking at a 10 millimeter sample of blood taken 5 minutes after the injection. So 5 minutes after the injection, the concentration in micrograms of penicillin per milliliter is going to be 152 micrograms per milliliter. Well, if I take that amount and I multiply it by the 10 millimeter sample, what I end up with is I end up with this many micrograms of penicillin in that sample of blood. I do a similar calculation for an 8 millimeter sample 10 minutes after the injections happen. So the concentration 10 minutes after is going to be 118 micrograms per milliliter. If I multiply that by 8 milliliters, I get 944 micrograms of penicillin in that sample. How much more is present in the first sample than the second sample? Just the difference between the two will get you that answer. So your overall result here should end up being 576. And then the final question says that the penicillin concentration in micrograms per milliliter in the patient's bloodstream T minutes after the injection is modeled by this function P. So P is equal to 200 times B raised to the T over 5. If P approximates the values in the table accurate to within 10 micrograms per milliliter, what is the value of B rounded to the nearest tenth? So what I thought to do here is I'm going to take a data point from the table. I didn't want to go with the one that was 0 because that wasn't going to allow me to find my value for B. But if I go with this data point, if I put 5 in place of T and I put 152 in place of P, I can solve this for B. This is actually super easy because look at this exponent. 5 divided by 5 is actually 1. So this is really just 152 is equal to 200 times B to the first. And what I end up with, if I type 152 divided by 200 into the calculator, I end up with a value that rounds to 0.8 when I round that to the nearest tenth. I could have done that with any of these other data points. The only issue would have been I'm going to end up with an exponent here. Right? Think about doing this with the data point 10, 118. I'm going to have 10 divided by 5 as the exponent. I'm going to have an exponent of 2. I'm going to have an extra step to do. I'm going to have to undo that exponent of 2. That's okay. You can definitely get the same answer that way. But this is a lot more efficient to just have that exponent being 1 from the onset, which is really the main reason why I chose the data point that I chose to do this calculation with.